Namaste children, welcome back again to this virtual class. In today's session we will be seeing the next part of the work and energy, that is energy. We will continue with energy. Before that, let us have a recap on what we have learned in the previous episode. We have learned about the work, right? Whenever we talk about work done is when a force produces motion. If a force is applied on an object, if it causes motion to the object, then we call it as work is done on that particular object, right? Now we define work as work done in moving a body is equal to the product of force exerted on the body and the distance moved by the body in the direction of applied force, right? Mathematically we have derived this as work done is equal to force into displacement. So whenever we talk about work done, we should remember that a body needs a force with that force. If the object covers certain distance or the object displaces, we call it as work is said to be done on that particular object, right? So this is what it says, work done is equal to the product of force and the displacement. Next we have seen about the unit of work done, right? The unit of work is joule. When a force of 1 Newton moves a body through a distance of 1 meter in its own direction, then the work done is known as 1 joule. Here the applied force must cause a body to have some displacement. If the applied force does not cause motion to the object, then 0 work is done on that object. In that case, the work done will be 0 joule. Next we have seen about work done against the gravity, right? Here, for example, if we lift any object above the ground vertically, or if we climb on a staircase, we able to lift our body against the gravity. In that case, the formula W is equal to F into S will not work. In that case, we have to use W is equal to work done is equal to mgh. Here M is the mass of the object, G is the gravity or the acceleration due to gravity, and H is the height to which the object has to be lifted, right? So this we have seen. Later on we have seen work done by a force acting obliquely. So in that case we have used another formula, right? So when we apply force to an object, the applied force causes motion in another direction. If the motion of the object is different from the direction of the applied force, we call it as the force acting obliquely. In that case we use the formula W is equal to F cos theta into displacement. Why? Because here all the force is not being used to move the body in the direction of applied force. Since we can see an angle between the applied force and the motion of the object, this angle we call it as cos theta. So the product of F cos theta and S will give you the work done, right? So work done when the force acts at right angle to the direction of motion, in that case we have seen 0 work is done on that object. Suppose you are carrying a heavy load on your head and walking to some distance. In that case the work done will be 0, although you are moving the object to certain distances, but the total work done on the object which you are carrying on your head will be 0. This is because you see the object is moving in that direction and you are applying force opposite to the gravity. So the angle, you can see very well that the motion is this direction and you are applying force on this direction. So right angle is formed. We know that cos 90 degree is 0. So F cos 90 degree will be 0. The whole term gets 0. So the work done will be 0, right? So this is what we have seen in the last episode, and we have seen that work done will be sometimes positive, sometimes negative, and sometimes 0. Here the work done will be negative if the force acts opposite to the direction of motion. For example, if you are kicking a football, then football rolls down on a ground. After traveling certain distance, the ball stops, right? Here frictional force is acting opposite to the direction of motion of the ball. Here the applied force and the direction of motion both are in opposite direction. So in that case the work done will be negative. In some cases the work done will be positive. Work done is positive when the force acts in the direction of motion of the body. Suppose if you are pushing an object then the object moves in the direction of the applied force. In that case, the work done will be positive. Work done will be 0 when the force acts right angle to the direction of the motion of the body. Just before we have seen, if you are carrying a suitcase or a school bag and walking along a road, then the work done on the school bag or the object which you are carrying on your head will be 0, since they make right angle, an angle of 90 degree between the applied force and the direction of motion of the body. So on the basis of this, we can say the work done on an object will be positive, negative or 0. So on what condition the value of work done will be 0, on what condition the work done will be negative and 0, all these things you should know. So moving further, in today's session we will be learning one of the most important topic, that is energy. Dear students, if a person can do a lot of work, we say that he or she has a lot of energy, or he or she is energetic, right? You are also very energetic, right? In physics also, anything which is able to do work is said to possess energy. Hence, energy can be defined as the ability to do work. For example, to cut a log of wood into small pieces, we have to raise the axe vertically above the log of wood, and some work has to be done in raising the axe. Since we are doing work on the axe, since we are lifting the axe to a certain height, we are doing work because the motion of the axe is against the gravity. We have already studied that if anything is lifted above the ground vertically, then work is said to be done on the object. Once the axe is raised up, and from there if you release it, then it falls on the wood and the wood gets splitted, or we can able to cut the wood. How it is possible? Dear students, you should know the amount of energy possessed by a body is equal to the amount of work it can do when its energy is released. So in the case of raising axe, when we raise the axe, some amount of work is done, right? So the amount of work done on the axe is equal to the energy possessed. So in order to do that work, that is raising the axe to a certain height, we must supply equal amount of energy. So that energy gets stored onto the axe. When we release it, immediately it comes down onto the wood and it splits the wood, right? Now that energy is used to carry out the work. From there the axe comes down and splits. No, here the energy stored in the axe does this work. Dear students, energy is a scalar quantity. Since it does not have any direction, we know that scalar quantities are those physical quantities which have only the magnitude but will not have any direction. Since here energy also, it does not have any direction, only the magnitude it has. So energy is a scalar quantity. Let us talk about the unit of energy. The SI unit of work and the energy both are same. We know that the unit of work is, or work done is joule. So the same unit the energy also has, that is joule. When work is done, an equal amount of energy is consumed. Keeping this in mind, we can define 1 joule of energy as the energy required to do 1 joule of work is called 1 joule of energy. So here joule is a small unit of energy, so sometimes bigger units are also used in terms of kilojoule. So you should know that 1 kilo is equivalent to 1000 units. So here 1 kilojoule will have 1000 joules of energy. So for doing numerical problems and all, these units, smaller units and bigger units, we usually use. We have learned that energy is the ability to do work, right? So this thing you are very much clear. Now let us talk about different forms of energy. If we talk about different forms of energy, there are different types of energy we see in and around us. They are kinetic energy is there, potential energy is there, chemical energy is there, heat energy, you are much familiar with heat energy, light energy with which you could see me, with the help of light, right? So light energy is there, sound energy, electrical energy. If no electric power, then the lights could not work. So electrical energy also you are much familiar with, nuclear energy. So these are all the various forms of energy. And we will talk about only two forms of energy. One is kinetic energy and another one is potential energy. Let us learn about what is kinetic energy. A moving cricket ball can do work in pushing back the stumps, right? When the bowler balls, immediately when the ball hits the stump flies away, right? So here the moving cricket ball can do some work in pushing back the stumps. This is because here while moving, the ball has got some sort of energy. With that energy, the stumps flies away if it hits, right? Moving water can do work in turning a turbine for generating electricity. So hydroelectricity and all you are much familiar with, right? So here when the flowing water falls on the turbine, then the turbine rotates. Due to this rotation of this turbine, the electricity is generated, right? So here the running water or the flowing water have some sort of energy. With that energy, the turbine starts rotating. Another example, moving wind can also do work in turning the blades of windmills. In the projects and all you might have made this windmill, right? When the air strikes on the blade rotates. With that the electricity is generated, right? You are familiar with this. The moving air can do some sort of work. So from this we can understand that whenever an object is moving, it has some sort of energy. This energy is known as kinetic energy. So kinetic energy can be defined as the energy possessed by an object by virtue of its motion. Simply we can understand that whenever an object is in motion, it must have some energy. That energy is called kinetic energy. Let us now learn the formula for kinetic energy. We know that the kinetic energy is the energy possessed by an object by virtue of its motion, right? The kinetic energy of a moving body is measured by the amount of work it can do before coming to rest. If it comes to rest, at that time the energy transformation we will discuss in the later section. Let us understand how the formula for kinetic energy be derived. Suppose a body such as ball of mass m and moving with a velocity of v is at position A. When the ball is in motion, here presence of air can oppose the motion of the ball. As a result of this, what happens is gradually the speed of the ball decreases and finally comes to rest. During the motion, it must have covered some distance, right? From A to B, it has covered some distance. So we can say that when the ball is in motion, it has done some work. So we know that work done is equal to force into displacement. Now at position B, the kinetic energy is 0 because the body is completely rest. This means that all the kinetic energy of the body has been used up in doing the work. So kinetic energy must be equal to the work done. So we can write it here as kinetic energy is equal to work done. So here work done is force into displacement, so we can write it as kinetic energy is equal to force into displacement. Here we assume initial velocity as small letter v and final velocity as capital V, and it has covered some distance, so displacement we will write, and acceleration is in opposite direction. By using the third equation of motion, we know that capital V, that is final velocity square, is equal to small v initial velocity square plus 2as, right? Since in our case the initial velocity is small letter v and final velocity is 0, that is capital V is 0 and it has the displacement s, and the acceleration of the ball will be minus a. Substituting these values in our equation, then we will get v is here 0, right? 0 is equal to v square plus 2, here a is acceleration is minus a, then s. So we will get here v square is equal to, here whole term minus when goes this side plus, so 2as. From second law of motion we know that F is equal to ma, right? Here a will become F by m. If you substitute the value of a in the above equation, then we will get V square is equal to 2 into, in place of A we will write F by M into S. On rearranging this, we will get F into S is equal to mv square divided by 2, and we know that F into S is the kinetic energy possessed by the moving ball. So, in place of F into S we can write kinetic energy. So, kinetic energy is equal to half mv square. So, this is the equation for kinetic energy possessed by the object during its motion. So, dear students, a body of mass m and moving with a velocity v has the capacity of doing work which is equal to half mv square before it stops. So, when the object is in motion at that time, the kinetic energy possessed by the object could be found out by using the formula half mv square. Here m is the mass, v is the velocity. From the formula of kinetic energy, it is clear that the kinetic energy is directly proportional to the mass of the body. That is, if the mass is doubled, then the kinetic energy will be double. Similarly, the kinetic energy of a body is directly proportional to the square of velocity of the body. What does it mean? If the velocity of the object is double, then the kinetic energy will be 4 times. If the velocity is halved, then its kinetic energy becomes 1/4. So, this way, by using the formula of kinetic energy which is half mv square, we can solve various numerical problems. Let us now solve some of the numerical problems. Now look at the question, how much work should be done on a bicycle of mass 20 kg to increase its speed from 2 meter per second to 5 meter per second. Now in the question we need to find the work done. We know that work done is equal to the kinetic energy. Here you see the body is already in motion, that is initial velocity is 2 meter per second and final velocity is 5 meter per second. Now during its motion it must have covered some distance, right? So the total work done could be found out if we know the total kinetic energy, or the change in kinetic energy will give you the total work done. Firstly, we have to find the initial kinetic energy, then secondly the final kinetic energy. So change in kinetic energy is equal to final kinetic energy minus initial, right? We have initial velocity and final velocity. So first we have to find initial and final kinetic energy from the mass and the velocity, then we can find the change in kinetic energy. Let us see how it could be done. In the question it is given that mass is equal to 20 kg, right? So in the first case the velocity is 2 meter per second. We know that here kinetic energy Ek, that is initial kinetic energy, is equal to half mv square we will use. On substituting the values we will get a half into m is 20 kg into v is 2, 2 into 2 is 4, here 2 gets cancelled, so we will get 40 joule of work, that is the kinetic energy, initial kinetic energy is 40 joule. Now in the second case we have to find the final kinetic energy. So here mass remains, mass is again 20 kg, but velocity is 5 meter per second, right? So substitute the values here, again half into m into v square. So here half m is 20 kg multiplied by 5 into 5 is here 5 square. So upon solving this we will get half into 20 into 25, here 10, here we will get 250 joule. So initial kinetic energy is 40 joule, whereas final kinetic energy will be 250 joule. Here we can find the change in kinetic energy, right? Change in kinetic energy is equal to Ek final minus Ek initial. So we have Ek final as 250 joule minus initial as 40 joule. On doing this we will get 21 joule. So total work done will be 210 joule. This way such type of numerical problems could be solved out. Hope you understood the numerical problem. Likewise you can find more other problems for practice. Now let us understand what is potential energy. Now suppose a brick is lying on the ground. It has no energy, so it cannot do any work, right? So the object which is on the ground, it cannot do any work, right? Let us lift this brick to the roof of a house or certain height from the ground. Now some work has been done in lifting this brick against the force of gravity, right, which is equal to mgh. Very correct. This work gets stored up in the brick in the form of potential energy, and if the brick falls, then what will happen? The brick can do some work. If it falls on the window pane, and then it can break window pane. So the energy of brick lying on the rooftop or at a certain height is known as gravitational potential energy, because it has been acquired by doing work against the gravity. So it is called gravitational potential energy. Another type of potential energy is elastic potential energy, which is due to the change in the shape of the body. The change in the shape of the body can be brought about by stretching, compressing, bending, twisting, etc. Some work has to be done to change the shape of the body temporarily, not permanently. This work gets stored in the deformed body in the form of elastic potential energy. When this deformed body is released, it comes back to its original shape and size, and the potential energy is given out in some other form. For example, a wound up circular spring in a toy car. You are much familiar with the toy car and all, right? So when you rotate the key, here what happens? The spring gets compressed. Here the deformation of spring takes place. The spring gets compressed. Once you release the key, what happens? The key once again, it comes back to its original shape. By doing so, what happens? The car starts moving. So here the potential energy has given out in the form of some other energy. The motion we can see here, kinetic energy we can see. So this is what potential energy is. In simple way, we can understand potential energy as it is a form of stored energy. For example, water in a dam, it has lot of potential energy. If it is released through a pipe, then the water flows with great speed, right? So where does the force come from? The force is due to the stored energy. So potential energy is simply a stored energy which an object possesses. This stored energy is achieved only if the object is above the ground level. If the object is on the surface of the earth or on the ground, then it will have zero potential energy. It cannot do any work on any object. On the basis of what we have seen just now, we can say that the energy of a body due to its position or change in shape is known as potential energy. Actually, the energy of a body due to its position above the ground is called gravitational potential energy, and the energy of a body due to change in its shape and size is called elastic potential energy. However, the gravitational potential energy as well as elastic potential energy are commonly known as just potential energy. Let us now understand how formula of potential energy could be derived. The potential energy is due to its higher position above the ground, and it is equal to the work done on the body against the gravity in moving the body to that position. So potential energy could be found out by the work done against the gravity. We have already studied that the work done against the gravity is equal to mgh. Here m is the mass, g is the gravity, and h is the height to which the object is lifted. On the basis of this, let us understand how the formula of potential energy could be derived. Let us understand the formula of potential energy. Here you see an object. If the object is raised to a height, say for example h, the object is having mass m, then the object needs to be applied force against the gravity. We know that every object is attracted towards the earth with some force. We call it as gravity. The gravitational force with which the object is pulled towards earth give you mg, right? Here we have to apply force against the gravity. In order to lift the object to a certain height, a work is said to be done on that object, right? So here work done is equal to force with which we are lifting the object to a certain height. That height is the distance, right? Here the force is against the gravitational force. We know that the gravity have the value m into g, and distance is the height to which the object is lifted. So this will be our height. This work gets stored up in the body as potential energy. Thus, potential energy can be written as potential energy is equal to m into g into h. Here m is the mass of the object, g is the gravity, and h is the height. Hope you understood how the formula of potential energy could be derived. On the basis of this, let us do some numerical problems. See the question: if acceleration due to gravity is 10 meter per second square, what will be the potential energy of a body of mass 1 kg kept at a height of 5 meter? See here, acceleration due to gravity, the value of g is given as 10 meter per second square. Mass is given as 1 kg, so m is equal to 1 kg. Height is given 5 meters, so h is equal to 5 meter. What we need to find? Potential energy we have to find. So here potential energy is equal to, we know the formula, m into g into h. All the quantities are given, just you have to substitute. Here mass is 1 kg, g is 10 and height is 5 meter. So upon solving this, we will get 50 joules of work is done. How simple, right? Let us see another numerical problem. Now look at the second question. A bag of wheat weighs 200 kg. To what height should it be raised so that its potential energy may be 9800 joules? The value of g is given as 9.8. So firstly we write the given quantities. So mass is given as 200 kg. Secondly, the potential energy is given. Potential energy is equal to 9800 joule, right? Now the value of g is also given, 9.8 meter per second square. Then we have to find the height, h we have to find. We know that potential energy is equal to m into g into h. We have to find here h. So we have to rearrange. So h is equal to potential energy divided by mass into gravity. So potential energy is given as 9800 divided by mass is 200 multiplied by 9.8. See here, the value of g is 9.8 and the potential energy is 9800. So on solving this, we will get 1000, right? Here height is equal to 1000 divided by 200, 2 zeros gets cancelled. So height is equal to 10 by 2, which is 5 meter. So how easy, right? Now the only thing is you have to rearrange the equation. Upon rearranging and substituting values in the relation, you will get the height or other quantities in 1 or 2 steps. Hope you understood the numerical problem. Likewise, you can practice more such numerical problems for practice. So dear students, that's all we have for today. With this, I would like to conclude. Before concluding, I would like to give some easy home assignments which you can practice at home. Here is your home assignment. Here are the home assignments. How much work is done when a body is of mass m is raised to a height h above the ground? Second question is, write an expression for the kinetic energy of a body of mass m moving with a velocity of v. Third question, which would have a greater effect on the kinetic energy of an object, doubling the mass or doubling the velocity? This we have already discussed. What is the kinetic energy of a body of mass 2 kg moving with a velocity of 5 meter per second? So here mass is given, velocity is given. Just you substitute the values in the expression, then you will get the kinetic energy. The last question, a load of 100 kg is pulled up by 5 meter. Calculate the work done. Similar kind of question we have already practiced. Likewise, you can do this problem also. Very easy home assignments, right? Do all these home assignments today itself. See you all on another day with a new topic. Till then, keep learning. Take good care of yourself. Bye.